Good morning, everyone. My name is Tiffany Talton. I'm a second-year student at Hines College of Public Policy and Management. I'm also the president and founder of CMU in Puerto Rico, which is a student-led group focused on a resilient recovery for Puerto Rico through agroecology, cooperatives, and solar power. We take a trip every year. And it's my distinct honor to present to you our speakers today. Our first speaker is Mr. Paul A. Salvador, a professor of materials science and engineering at Carnegie Mellon University, and he's the interim director of the Interdisciplinary Professional Master's Program in Energy in the College of Engineering at CMU, Energy Science, Technology, and Policy. Our second panelist today is Jessica Lyman, a consulting manager with the Black & Veatch Management Consulting, focused on helping electric utility clients implement and derive value out of advanced metering and distribution automation technologies. Our third panelist is Shelley Hagerman, a senior consultant in West Monroe Partners Energy and Utilities practice. As a subject matter expert in distributed energy resources, Shelley contributes to projects and thought leadership around topics including energy storage, transportation, electrification, and rate design. Our next panelist is Pranav Chopra, who was born and raised in New Delhi, India. After his undergraduate degree at Iowa State, he came to the Master's in Energy Science, Technology, and Policy. After 5 years at Lutron Electronics, he transitioned to his current position at DFB Sales. And finally, we have Shrikant Subramanyam, a senior energy systems engineer at R3 Energy, a New York-based startup that specializes in energy efficiency and demand-side management for real estate portfolios. Welcome to our guest.
Thank you. Good morning, everybody. It's great to see you all here. As we've been hearing throughout the week, and as we'll hear more today, the energy sector is this extremely broad area, and it takes all sorts of disciplines to move it forward. So what we thought we would talk about today is some innovation in the education of energy experts, particularly two that we're proud of in the College of Engineering, the Energy Science, Technology, and Policy program, which is a professional master's degree that three of our panelists have graduated from. And the Engineering Public Policy, which is a standalone department that has undergraduate and graduate degrees on all areas of engineering, and including energy. And so one of the unique aspects of this is that the panelists have all had a specialization in their education in energy. And so we thought we would discuss, now that they're in their mid-careers and are leading the energy space, how those sort of unique experiences have benefited and how education in the energy space can be innovated in the future. So with that, I thought I'd just let the panelists do most of the talking today, hopefully, but just set up the stage. So I thought we might just start with that particular question in general. How has focusing in energy with a graduate degree sort of helped you or differentiated you in your careers thus far?
Who wants to start?
I could start.
Can we just go down the line?
First of all, I just want to say how great it is to be back on campus. And just want to thank the university and the CMU Energy Week team for inviting me here. This is definitely a great panel to be on because it helps us connect with future graduates here and let them know what the outside world is like. And coming to your question, Paul, personally speaking, I am a mechanical engineer by training, and the first couple of years out of school, I worked in mechanical maintenance for a power plant. And in maintenance, the goal is to keep the plant running. So you basically have to keep the equipment functioning at its ideal state as long as the plant needs to operate. And that was basically a one-track mind that we had as maintenance engineers. But something that I learned after coming to CMU and being a part of the EST&P program is the effect that operating that equipment has on the overall cost of operating, say, a property or a portfolio. say, real estate portfolio, because it's very interconnected with utility costs. And that's an added perspective that I received. It's not just about keeping the equipment running, but also optimizing how that equipment functions throughout the course of a day or a week or a year.
Thank you also for, I'm pleasure to be here today. And I also encourage all of you to take advantage of this opportunity this week to be here, because I know that for me, 3 years ago, in 2016, the first year this event was held, that's actually how I landed my current job. So it's a great opportunity to learn more about the energy industry and network. So I hope you guys all take advantage of that. Doing energy in engineering and public policy was really beneficial for me getting into my career at West Monroe Partners. It allowed me to gain subject matter expertise before I even started and having a really deep understanding of the electric industry. So being able to walk in day one, really familiar with the industry, whether it's with FERC, NERC, distribution, transmission, et cetera, generation, was a huge value, and it allowed me to go on to a variety of projects with a very quick learning curve. So I think it's a great opportunity to be in these interdisciplinary programs that really prepare you for an energy career.
Yeah, so Paul, for me, I'd say the multidisciplinary aspect of the program helped me the most, because leaving after I was done with the program, I didn't know what I would focus on, or sometimes you don't know what kind of career opportunity finds you or you find it. So now I focus on building energy, and that's a big part of my job. And having a few courses in lead architecture and being exposed to that really helped me excel in what I'm doing now. So I'd say if I were to pick one thing that really helps from the program, such as ESTP, it would be the fact that you can spend a lot of time on many different aspects and then use that later in your career.
So my turn, I guess. So similar to my fellow panelists, I appreciated the interdisciplinary degree because I've been able to problem solve in a lot of spaces since my graduation. I'm with Black & Veatch now, but this is actually my third job since graduating in 2012. And all of the jobs have been very, very different, from doing federal energy policy consulting to now working in the utility space. And I don't know how many of you were at the C3 gentleman's presentation yesterday. He had that lovely slide that talked about the whole sort of life cycle of a utility, from generation to distribution to transmission to customer. I can get dropped in any one of those places right now and be functional, thanks to the education and training I've had at ESDP, because they taught me about that whole life cycle and where there's value, and how energy efficiency and how new technologies and how policy impact each of those touch points.
Thanks, everybody. I think staying along that line that you brought up, the programs at Carnegie Mellon have been designed specifically to be interdisciplinary, as you brought up, Pranav. Maybe some of the other panelists can also expand on the nature of that interdisciplinarity that are built into ours, and how you see that in the energy space and how it's been useful in your career.
Maybe as the EPPer here, I would like to talk about how I really value the energy policy aspect of it, because I think in the electric industry in particular, as well as the rest of energy industry, everything's driven by policy, whether it's federal, state, or local policies, initiatives. You have your federal investment tax credit for solar. You have your credit for rebates for electric vehicles. You have at the state level and regulatory levels, you have utilities have to file to their regulators to get approvals for spending. So everything's about thinking in the public policy lens, and I think that's just a very useful skill to develop. And so that's one way that not doing just a strict engineering degree really helped me in my current job.
So building on that, as a part of my ESTP degree, I was able to take classes in the Tepper School of Business to support my master's. And what I valued from that experience was that while policy drives a lot of things, so does money. Let's be honest, money drives things. And so what I've seen now, translating into the business world, is that both policy and money are driving decisions that companies are making and how we can help them make them. One particular one that I have an example, so utilities have a storm budget. So that is the amount of money they spend to recover from storm events, ice storms, windstorms, that impact people's ability to get power. Their storm budgets have gone up exponentially over the last 10 years as a result of larger and larger storm events that people are attributing to climate change. So understanding how to communicate that, hey, there's a business driver here in addition to a technical, in addition to a policy construct is really valuable.
So specifically one class, actually I remembered it not too long ago, was life cycle analysis. I'm sure some of you might be taking that course right now. It's a key course, especially if you're thinking of doing anything to do with building materials, because now what DFB, the company I work for, is launching is any interior product that we make needs cradle-to-cradle certification. Now, it's most people that are asking for this don't know what cradle-to-cradle is, but I happen to know what it is, so I can do a lot with it. But it's very important to understand that moving forward, the new buildings that are being built that are pursuing a LEED certification or a WELL certification, cradle-to-cradle is a key aspect of any material, whether it's that divider you see in the back or the fabric you see behind me on this curtain. It's going to need to be cradle-to-cradle certified.
Just to add to what everyone's already said, one of the courses that we studied as part of the core courses in the ESD&P program was energy policy. And I did happen to take some other elective courses on that as well. And the way it's helped me in my career is that R3 Energy, the company I work for, we work in the field of building analytics, which is a new but very rapidly growing field. And our company was one of the first 5 New York State certified real-time energy management providers. And this is something that even the state was grappling with, trying to come to terms with, and it's helped us work in conjunction with New York State and local agencies in New York and help them chart policies for implementing energy management and building analytics on a wider scale in the state of New York.
Thanks, everybody. I think one more really high-level question, and I'm sure that all the students out here want to hear some more personal kind of things of how your career trajectories have gone. All of the programs at Carnegie Mellon are built off of this concept where there has to be some core strength. So I should say these programs that we're discussing today are engineering programs. There are also other energy programs across campus. But in the engineering, we sort of focus on having core strength in a singular disciplinary area, mechanical engineering. And even in EPP, you're almost always required to have a core competency in another area. How do you see education in the energy space growing in the future? Is that concept of having a real core and energy on top an important area? Or do you see that energy can be sort of its own standalone educational discipline as you move through your career right now?
Well, I'm of the opinion that energy engineering is definitely a growing field, but there's definitely linkages that it has with other core engineering fields like mechanical or electrical engineering, even civil engineering. So while I'm myself an energy engineer and I would love for it to be a standalone field on its own, I do feel that the interdisciplinary framework definitely helps because it allows people to have a different perspective. For example, like I said in the beginning, I was a mechanical engineer myself, and so my focus was just on making sure the equipment ran as it was supposed to. I didn't really have an idea of how it works, to influence costs, let's say in in a commercial building setting. So that would have been a very narrow-minded approach had I not been exposed to the interdisciplinary framework of the EST&P program.
Yeah, I'd say that makes a lot of sense. In terms of in the energy industry, it really is incorporative of kind of all of our traditional fields in general. So in my undergrad, I did an engineering science degree, so it was very interdisciplinary as well. And what I was able to do is then we had some elective courses that focused on energy. So for example, my junior year, I took a solar PV and fuel cell design course. And so that was really awesome to start getting experience in the energy space, and it really helped prepare me to actually get into the PhD program here because I ended up doing 2 years of fuel cell research in undergrad. So it was a really good transition to then engineering and public policy here. And then I'd say continuing on at Carnegie Mellon in engineering and public policy, I think, whether it's, quantitative methods to public policy analysis or power systems course, all these very different classes, I think were all valuable in their own right. Because again, energy space, it covers a lot. And so have all these tools in your belt is great.
Yeah, I think energy engineering certainly has, if it keeps having the momentum and interest levels that it does have now, it does have the capability of its standalone program in the future, just like some sort of an agriculture engineering is today. I don't see the need for studying energy going away anytime soon. So yeah, definitely, I think that's possible.
So I'm sort of in the middle, and I could argue this either way. But I think that comes from consulting, because I can always argue everything either way. So personally, I'm a mechanical engineer as an undergrad, and I have used it, but I have not wanted to, because when I walked away from my mechanical engineering degree, I was like, I would never want to design an HVAC system, ever. However, what I learned is that HVAC systems are really important to energy building design, right? And that's a key function of making our buildings more efficient. So that was interesting. But as far as an engineering degree, I think what we're seeing in general is our core disciplines like mechanical engineering, electrical engineering, becoming inherently a little bit more mushy and interdisciplinary. So I think that leaves an opportunity for energy engineering as a standalone. So while I'm a mechanical engineer, I concentrated in control systems. So I had to do electrical classes in order to meet that concentration. So by default, I was already crossing the border into electrical engineering as a part of my undergrad. I think what we're going to see is a trend, and maybe we'll see more of that, because there are very few jobs in our current marketplace where one person sits and does one task for their entire career. Most people have more movement in the marketplace. And in order to sustain that movement, people need to have broader understanding and broader skill sets that they gain both from their academic experience and from their professional experience. So I could totally see this.
Thanks. I think maybe from a more of a career trajectory in your own personal career trajectories, how do you pivot from that sort of traditional engineering degree into your current space? And sort of maybe a follow-up is, as you move into your mid-careers and you're going to be hiring and leading the energy space, how do you see your own background in that education in the energy space as a real value asset and looking for that in other people, perhaps? That's sort of a long question. You can take the first one if you want.
I like this question, only because I'm hiring a lot more people now. It's very exciting. So what I valued about both my engineering degree and the interdisciplinary degree from the ESTP is the core concept is it teaches you to problem solve. It teaches you to look at problems and work through a methodical set of steps to come to a solution. And you can break down the problem into parts, Lagrangian decomposition. Does everybody remember that class? Break your problem into parts to tackle the individual parts, in a meaningful manner and in a tactical method. So when I look for as I look to hire people, we're hiring a lot, to help build this energy space, I'm looking for people who can also problem solve. And they can problem solve with the thoughtfulness of what's behind the problem. What's the policy that's driving these business decisions? What's the technology that I could use to solve these problems in the energy space? What's coming onto the market? How can I incorporate two technologies to meet the goals? So that's really what I'm looking, what I have found valuable to my career and what I look for in others is the ability to sort of look around and problem solve.
So when I first started at Lutron, right out of the program, I was focused on doing mostly rebates, mostly for lighting, where LEDs were being pushed a lot and encouraged, and the government was encouraging people to use LEDs more, and they would give you PSE&G and Con Ed would give you a certain amount of money back. Looking at the trajectory from what I did then to what I do now, they have no similarity at all, and part of that is, most of that is me driving my career in a direction I wanted to head into, but there's also a small part of it where I stayed flexible enough where other factors, or I kept my doors open to other opportunities that kept springing up. So I'd say, again, I know we've already talked about this, but the multidisciplinary part of the program allows you to do that. So I would just say that career trajectory-wise, keeping an open mind is very important. Allowing new opportunities to come and you giving it a try are very important in whatever you end up being. And if I were to look for someone coming out of this program, and that's exactly what I would look for.
I think maybe the two areas I like to talk about are projects and project management, and then also just getting involved in your communities and your school. So for the project management, I think that, that's a quality that we value highly in the consulting industry, because obviously it's project-based. So I think, I know when I was doing both undergrad and grad that most of my courses ended up having projects. So I would just encourage to really embrace those as opportunities to develop those skills, to work with your team members, to go through the process of problem formulation, developing an approach and strategy, understanding how it's delivering value. Thinking through all that is great practice for after you graduate. And then, let's see, and the other thing I was going to talk about, sorry, now I forgot. My second piece. Involvement in your communities and school programs. So, for example, if you're not currently in a program, or maybe you're in one of your traditional departments, then get involved with CMU Energy Club. If you're interested in energy, show things that show that you're more than just applying for some random job, and that you're actually passionate about this industry, because I think that goes a very long way. Read the news. I started following different things on Twitter, although I don't tweet. I've never really tweeted, but it's a great way to kind of keep up with current things that are happening in the industry, and then take those and do some research about it. And you'll find that then you can have conversations with people from all across the industry and just show you that you're knowledgeable about the industry. And I think that will set you up for a lot of success.
I just want to say that since the time I started R3 Energy, it was actually my first job after CMU, and it was quite fortuitous that I got a job there. Wasn't anything special. It just so happened that I was looking through job boards, and I found this one job on LinkedIn actually, and I just happened to call them, and I sent them my resume, and they thought I was a suitable candidate. Unfortunately, it worked out very well. It's been, as far as the trajectory goes, it's been very organic in the sense that we started out doing energy procurement. For those of you who don't know what that is, there's two components to your utility bill, which is delivery and supply. The delivery component is fixed, but the supply can be negotiated with different third-party suppliers. That's what we started out doing, and then we sort of veered into consulting, and specifically more on the building analytics side. And so I would concur with Pranav that it's best to keep an open mind. There's no telling what's going to happen in the future. As far as what I'd look for in people graduating with a degree from here and wanting to get into the energy field, personally, since I work in building analytics, I would want someone who has an analytical mind. Obviously, you want to, if you're analyzing how building uses its fuel, whether it's electricity or natural gas or any other kind of fuel, you want to be able to analyze why it's varying, how it can be optimized, how the usage can be not manipulated, but managed over the course of a given period. And then the other thing that I personally look for is people who have failed in the past. If there's someone who comes to me and says, "Hey, I've been successful all through my life," that's actually I give negative points, because it means that if you're ever faced with an issue where you're very likely to fail, you may not know how to face it. So personally, I look for people who've failed in the past and who've sort of come back from that and have become successful.
Thanks. Time is flying by, and I'm glad that everyone is having a chance to talk. There was a question from the audience, and there was one last question on this big thing. I guess the big question is, what do you think is missing, or what's coming down the pipeline that's important for educating in the energy space, from your perspective of your jobs? But the question was specifically with respect to data sciences and artificial intelligence. How important is that going to be in the future in energy, from your specific areas?
Sure. In my opinion, it's a huge opportunity. There's a lot of room for AI in building analytics, personally speaking, because that's my field of expertise. And even there's for any energy efficiency upgrades that are required, the utility or concerned state agencies are always willing to give out incentives, and their focus on building analytics has gone up over the past couple of years because they see what a valuable asset it is. And then the other area that I see of note is decentralized grids. So, for example, Con Edison, the major utility in New York, recently implemented a program whereby communities in the Brooklyn and Queens area would be able to install a microgrid up to, say, 50 megawatts, just so that they could avoid the construction of a substation that would have otherwise cost them $1.2 billion to supply the same amount of electricity. So there's a lot of focus on decentralized grids or microgrids, as they call it.
I think a couple different components. Also reflecting on the presentation yesterday from C3 AI, I think thinking in terms of predictive analytics for maintenance is one thing in terms of the equipment for predicting failures. I think a lot of utilities are looking into advanced distribution management systems, or basically kind of the core of their grid operations. And so being able to take the data from there's the smart meters and from generations, or all these things. So for example, there's sometimes ADMS include a DERMS, or that's kind of a growing thing, is distributed energy resource management system. And so how are you going to take all these million endpoints of data, and how you need to forecast what your generation will be from these intermittent resources? So there's a lot of data analytic opportunities, and also just to further predict what the net load will be, so you can actually be nimble with your grid resources to improve and sustain reliability and resiliency. And then also, I think, aside from that, for data analytics, it's everywhere in a utility, and they are investing into these data platforms. And in order to, it's great, you spend millions of dollars, but how are they going to get the value back from it? And that it's all up to us to actually help them to think about the applications, figure out how to best leverage that opportunity now that we have these platforms, how to get the most from it.
So in my line of work, machine learning plays a big role. If you think about it, the focus in the new age is the built environment. Human beings spend 80 to 90% of their time inside a building, yet we spend most of the time making sure the building looks great from the outside looking in. So now the focus is going to be like how a person, whether they're sitting in that corner of the room or back there, how are they going to be the most comfortable when a person's working in their cubicle at work or their private office. Machine learning tools like thermostats, like the Nest thermostat by Google, they actually see what your daily habits are when you come in every day, what temperature you like it every day, and learn that so that person sitting in that cubicle, that office is very comfortable. I think that is one area that hasn't been developed as well, and that's going to be something that's going to be that's going to play a big role in the future.
So all of my fellow panelists talked on, artificial intelligence, data analytics. All of those are key trends. So I've got nothing else to add there. What I will pile on with was with our gentleman from C3 yesterday who got on his soapbox, rightfully so, about data security. I think that is a tipping point in this marketplace that we're going to start seeing more conversations about, because we've gone from basically an analog grid to a digital grid. And with that, it opens up the opportunity for exposure and risk. So, and not just at, China hacking utilities to, hey, I can read your meter remotely from my computer, so I know when you go on vacation. So I can go rob your house, right? Because I know you're not gonna be home. That kind of data insight is possible now. So we're not talking just large scale things. We're talking, small scale, daily, things that would have impact to you directly as a customer or person that you need to be concerned about and think about as far as your data privacy. So I think the big space is going to be who has a role there. Is it a regulatory one where we, promote regulation to, define how we do data privacy and who has access to it? Is it a consumer-driven one? Is it a utility-driven one? Is it a platform-driven one? There's going to be a lot of conversations there.
I'd also like to add one more thing, if I may, is around transportation electrification. I don't think we've talked about that on this panel, but that is huge. And it's a great opportunity and challenge for electric utilities. It's an opportunity for one, because, with more and more distributed energy resources, which are phenomenal, provides us a green electricity mix. It also erodes the revenue base for utilities. And so for them to continue providing the reliable service that we all count on for our daily lives, they need some extra, load to manage. So with electric vehicles, that's a lot of increased load, but then you have, at one particular neighborhood, everyone, it becomes a fad. Let's all get our electric vehicles, and then all of a sudden your transformer can't handle that sudden increase in load. So there's a lot of things to think about there from many different perspectives about the effect of transportation electrification. Again, looking at all the opportunities that it really does bring, the challenges, and there's a lot of movement, especially in the West Coast in California, for example. They have programs for your residential EVs, your multi-unit dwellings, your commercial workplaces, and then also thinking about medium and heavy-duty fleets, and a whole host of problems. Again, it's complex. So I think that's another big topic area in the next few years.
Okay, I think we have time for a question that was sent over from the audience. I think the question here is related to the interdisciplinarity and the breadth of energy. But with all of the policy and energy masters, even though there's a core in concentration, how much technical content do you continue to use from your education? And do you is an energy degree setting you up more for a broad kind of job, maybe regulatory or policy, or can you retain your technical depth and move into energy in that?
You can keep as much depth as you want to keep. It's a personal decision. So I still draw volt-var diagrams on my whiteboards every once in a while when I am explaining power distribution to people and what ancillary services are. You can keep as much depth as you want. If you appreciate your technical depth, there are jobs out there for you that will appreciate that as well, and where you can leverage that. If you are like, I don't ever want to look at a drawing, I don't ever want to look at a graph again, yeah, there's a job for that as well.
Yeah, so I think it really depends on what kind of role you end up going into. If it's a more technical, energy-driven role where you're running spreadsheets and calculations all day, you probably are going to use it more. However, I will say if you go on the other side of the spectrum, like I went into sales, but I use things like solar heat gain coefficient, R value, U value on a daily basis still. So it does stay with you, and no matter what role you go into, the technology aspect stays with you. But like Jessica said, that you don't have to. You can use it as much as you like.
For my firm in consulting, I think it's a mix. We obviously do a lot of business case analysis, building a lot of Excel tools and all that stuff, and making really visually pretty PowerPoint designs and all that. So those are my most commonly used skills. But then also, I'm able to take things a little bit further when needed. So one of my first projects was helping a utility understand the impacts of rate design on the adoption of solar and energy storage. So I did actually end up being the only one in my practice to have MATLAB, and then developing an optimization algorithm to help them understand that problem. So there's opportunities even when they're not maybe traditionally there. And then also in my current project, they had issues with where they were kind of managing their current project as an Outlook tasks, and I was like, well, I'm going to write a VBA code. I didn't learn VBA previously, but with my technical skills that I developed in coding with MATLAB, I was able to just learn some quick VBA and solve the problem. Now we can do reporting very easily, and so you can create some unique opportunities to really add value to your project and your clients.
Yeah, I would say that the breadth of technical expertise that you need to maintain is definitely a very personal choice, but to a large extent, at least in my case, it depends on the kind of clients you're dealing with. For example, the other day, I do a lot of sales and marketing at my job, so the other day I had to explain the fan laws and perform a regression analysis of temperature and their electric demand for a client. And working with buildings, a lot of these building owners know their buildings intimately well and the equipment in it, so they're very technically oriented. So it helps a lot to have that kind of knowledge. And then just one other quick point I want to add is that in a quickly growing field, it's always important. It's great to retain your technical expertise, because it also helps you, adapt to changes in the same field more rapidly than someone who might not have that expertise.
Thanks. Unfortunately, we're out of time. I know that went super fast, and we're happy you came back to visit us and give us some comments on the education aspects of energy, and we hope you appreciated that. So thank you all, and we're going to wrap up.
Thank you.
All right.
Thank you, everyone.
Thank you very much.